Yes, good evening, everyone. Uh, Last time we promised we stopped on primary apportionment, and then we promised that we shall proceed from there, maybe to take you back. We have our problem question here about overheads, where we had two production departments and also have two service departments. We saw the cost that we have to allocate in these whereby we said for primary apportionment, that was part A, which we worked upon, where we had to allocate these total costs in the four departments, that is the production departments, X and Y, and also the service departments, A and B. So today we basically want to see how we can go ahead to do part B, carrying out primary secondary apportionment using direct, step, continuous, and algebraic. I think we can do one or two, depending on time. Only, I think, to take you just a recap. Last time, this is what we did. We managed to do our overhead. So it's overhead apportionment distribution sheet. And this is how we got our costs. Of course, from the formulas up there, when I click into the figures, you see what we're doing. Yeah. So this was our working area. See how we came to get those. We got the total area, total book value, number of employees, and machine hours. So that was the basis of apportioning these total costs. So today we want to go ahead. We said secondary apportionment, like we go ahead and transfer these costs, the overhead costs that we had distribution in the service department, and transfer them to the production costs. So depending on the method that we're going to use, like we want to start with direct method. We want to see how we do transfer the costs from the service departments to the production department. And that is what we are going to do. So this is what we did last time. And today, going back to our question, we say that when it comes to secondary apportionment, we are going to allocate actually, so starting from our distribution, go ahead and allocate these costs. So given the following technical estimates are made in respective of the apportionment of service department costs. So these are the estimates, implying that they are telling us that Department A, under particulars here, means that Department A will distribute 50% of its overheads to X, then 40% of its costs to Y, and then 10% to B. Of course, that dash simply means that it is a distributing, so it cannot distribute to itself. It is getting its costs, distributing to the rest of the three. Same applies to Department B. It's also distributing 45% to X, 50% to Y, then 5 to A. So that is the interpretation of this. So now, using the direct method, we're told that there is no inter-service transfer or distribution. So meaning that costs of these service departments are simply going to distribute to production departments without distributing to the fellow service department. This implies that if it is Department A, we are going to get the costs of Department A, distribute them in X and Y without distributing to B, much as it has 10% for direct. We do not do inter-service apportioning or distribution. So for direct method, these percentages in A and B are going to be ignored. I repeat, for direct method, apportioning is only going to be done production departments. We are going to get the costs of A and B and transfer them to X and Y without A distributing to B and without B distributing to A. All right, I guess that is understood. So I'll come here because we said that we are going to start with our direct. We are going to start with our direct method. Just say here, let's call it direct method. Okay. So, of course, I'll start with my primary apportionment. We'll start with the costs. Primary apportionment. Apportionment. Then we'll have our amounts. We have X, Y, A, and B. So remember what I told you last time. Don't mind about my IT, but take what we are doing. Because at least I know we're going to answer on paper, not on computer. So just try to understand what I'm doing and don't mind about my whatever. And I said, when I keep quiet, you know, I'm just hustling with this thing. Okay. So now, whatever amount we see, remember, we go back and see from the primary apportionment, we are carrying this figure. You see that figure? That's the one that we want to put here. There. So, in other words, I'm getting so will equal to this, to that figure, because that is the total amount. See? Then this for X. So, in other words, in a very simple way, we are trying to get these last figures that we obtained. Say this for X and that. We're just going to transfer them here. Oops, sorry. I do. Anyway, this will also equal to this figure. This will equal to, see that for Y, I'm also going to Y. That figure is what I'm carrying. Then for B, it will equal to, I come to the last total. Okay. Then also B, we come to the last total of B. So I've simply tried to transfer those last totals that we got from the distribution sheet or what we did in the primary apportionment. So that is the reason why for each and every question that we have to find, the very first thing is to do primary apportionment. Now, remember that we got a total of these X and Y, then A and B. These are the total costs in those departments. Now, with secondary apportionment, all we need is to start with this sorry, to get this A, transfer these amounts in A into X and Y only without distributing to B. That is what the direct method tells us. So in our apportionment here, so after that, now we come here. Secondary apportionment is what we are talking about. Secondary apportionment. Secondary apportionment. Apportionment. And this is what is going to happen. Say that it is Department A that is going to distribute. It is Department A distributing, and it is distributing with this ratio. A is distributing 50 to 40. Now, when we come to this area of ours, here, if I call this a working area, maybe working area. So, Department A, Dept A, is going to distribute to X. So it means X is distributing X to Y in the ratio of 50. What ratio was it? The ratio of 50 to 40. So this 50 to 40, 50% to 40. If you know ratios very well, percent and percent can go away, and we also reduce. We can reduce this by 10, right? And when you reduce 50 by 10, we are getting 5. 2. Then we reduce 40 by 10 also, we are getting 4. So that's how we came to get this. That's how we came to get 5 to 4. That's how we got to get that ratio. Okay. It's Department A distributing. And when it is Department A distributing, that's what we're talking about. If A is distributing these amounts, so this means whatever we are going to do, we are multiplying this. So it means X is going to get 5. Actually, let me say total ratio here. I'll have my total ratio, which is equal to 5 plus 4 being equal to 9. So now that 9, meaning X will get. So now X is going to get 5, because it is getting 5, divided by the total ratio, which is 9. This is this total ratio we are talking about. Then multiplied with, it's going to be multiplied with this cost, because it is what we are distributing. So that is what we get. Then Y is going to get, because we said Y is getting 40%, which we reduced to 4. 4 divided by the total ratio, then multiplied with it will be multiplied with the same cost, right? So when it is multiplied with the same cost, now that is what you will be getting. Okay. So because this has been distributed, it means we are subtracting it from this. So here we have 3, 2. This one is getting nothing. All right. So this means that the reason why this one is minus, it is because at the end of it all, we have subtracted these costs from A. We have transferred them. So the total down here, when we add vertically, this negative will cancel out the positive, meaning we no longer have this cost has been distributed between X and Y. Okay. So also we do the distribution in B. So for the distribution in B, it is also second apportionment. Second apportionment. And now others are coming back. Yeah. Second apportionment. This is, sorry about that. This one is department B. So now when we come to department B, also here, department B, it is going to be in the ratio of, so B is what? Now department B is going to distribute to X and Y, not A. This is direct. There is no inter-service distribution. Right? So we are distributing 45 to 50. Now 45 to 50, we come back here as saying B is distributing to X. Okay. So we are saying that when we talk about X to Y, it will be equal to 45% to 50%. This is also, now when we reduce this, take note of this. Of course, percentages cancel out. Now, when we reduce this, I think we must reduce by the same magnitude. So 10 cannot go in all, but you see, if we reduce by 5, we have a 9 to 10. So guys, so do not hassle a lot with this reducing. If you cannot reduce, it is fine. You can still just say 45 to 50. It is very fine. 45 to 50 without reducing, it is also very fine. I repeat. So if you cannot do those things of reducing, you can just add, you can just say 50 to 40, like for department A, 50 to 40, such that your total ratio will be 50 plus 40, total ratio to be 90. This one, it can be 45 plus 50, total ratio to be that. So, because here, we have reduced total ratio, and equal to, I'm adding 9 plus 10. So, guys, take note of the solution has some mistakes, because you see that at times they reduced by 5 this side and the other, and they did not reduce, so things like that. So do not follow the same mistake. Make sure that you either reduce. If you don't reduce, add them the way they are. Now here, instead I would have added 45 plus 50. and I get 90. You get the same answer here. Okay, so in this case, me, I added the ratios and I'm getting 19. Now, when I come here to distribute, so when I come back here, and so we are distributing this in 9 to 10. 9 to 10. Okay, and let me just make this proper. Okay, so we are now distributing this amount to X and Y. So if we are distributing to X and Y, then we are having equals this X is to take 9, this 45, this 9 now, the ratio, which is 9 to be divided by, total ratio is 19. Then we multiply it with this cost that we are distributing, right? Okay, then when we come to Y, we do the same. We are distributing, we are saying Y is taking on 10 divided by the total ratio, which is 19, multiplied with the same, right? So it is multiplied by the same cost, and we get that. Again, this is going to be minus, because we have distributed it. We have transferred it 1, 2, 3. So that is how we came to get this, such that at the end here, when we are having our totals, right? So with our totals, if I say total, and you know the totals, I simply, here I mean adding this, we are going to add vertically, right? So yeah, simply say equals, come to table here. What did I do? So I'm adding from there up, down here. That's what I am adding, and I have that. Same way, I also add from up there, from here, right? Making some additions. Yeah, you see? That highlighted, those highlighted cells are the ones that I'm adding, right? Okay, so I'm adding from here up to there. So that is what I'm doing. So the fact that throughout I'm adding like that, so I can, yeah, I'm trying to beat time, but simply, you see, when we add this and this, that's the 0 we are getting. Add this and this, we get the 0. And now those are the total costs. So you see that at the end of it all, we are having the final figures. Y is taking on, X is taking on 1941, Y is taking on that. And that is how we came to do, that's how we do the direct method. Okay. So I think that is fine. And that's how we do the direct method. And the my totals. do that. So that is the direct method. Now, if we still have some time, let's do the repeated method. Let's do the repeated method. So with the repeated method, we come this one too. Repeated. Let's stop continuous method. Now for the continuous method, here the service departments also continue to distribute to each other. They continue to distribute to each other. Distributes the other, even the other one distributes to the other, just like that. Yeah, repeated until the cost distributed in the services is very insignificant, doesn't make any significant figure. So the same way we did there is the same. So allow me to copy this because it will not change. You see? I don't know if it will accept. Wow, it has done so. Yeah, at least this is what I needed. Anyway, now for this, I can just copy them there. Just say equals this. Remember that this one is the same, because the primary apportionment is the same. Getting it right from the distribution. Getting it from the distribution sheet, only that here it's just near for me. I don't want to go back the other side. So these are just issues of IT that are disturbing me, but just get to know that we are getting these figures. So like I told you, for all the methods, repeated, direct. So we start with the primary apportionment, always, right? So again, now that is our primary apportionment. Now we are going to, unlike in the other one, if department A, if I come here and I just, now, if department A starts to distribute in our secondary apportionment, if department A starts to distribute, but the ratio is going to change. Now, look at this. When we come back to our problem question, department A is distributing to X 50%, Y 40%, and B 10%. So meaning that unlike in the direct method, where A did not distribute to B, in this case, this is what I'm talking about, where A did not distribute to B, under here, A is also going to distribute to B, right, in that ratio. So again, when I just come to my working area here, and I talk of department A distributing. Now, department A in this case, let's first make it clear also here that department A is distributing to only X and Y, right? So only X and Y. But in this case, department A is distributing to X, Y, and B. So in the ratio of 50, 40, and 10. This is what you're talking about, 50, 40, and 10. So come here, we're saying that it is distributing to in the ratio of 50, that is 50% to 40% to 10%. So this will basically tell us that it is now reducing by 10 all over. See that you're getting 5 to 4 to 1. I told you that if you cannot reduce, it is okay. Simply go with those, all of them, right? So, but the percentages, just ignore, just know that they cancel each other. These are ratios. So total ratio, then for it is simply, what do we have? 5 plus 4 plus 1, giving us 10. So meaning that department A is going to distribute 5 to 4 to 1. Okay, now we come here. We're saying equals to these costs of A, equals to A will get 5 divided by this total ratio, which is 10, but I don't want to write it there, so I just put it myself here. Saying 10, then times now the cost that we are distributing, times the cost we are distributing. Guys, when you're following this video, at least even you also look at this formula function and you see what we are doing, because whatever we do here shows itself there. So that's what we get there if we distribute it that way. And oh, sorry. The other thing is that under the distributed, sorry, I'm forgetting something. You see, when we are distributing in the amount or the service that has the highest distributes first. I repeat, the service with the highest cost distributes first. So in this case, we are distributing for B. B distributes first in the first place. B distributes first. Okay, so meaning that we have to go back and see what B does. B is distributing 45, 50, and 5. 45, 50, and 5. So it is 45. Katono. Katono. Bikukoleno cost. Bikukoleno. Repeated and continuous. Togenda kusomera. Anti research. Nenze kukola corporate ngendo. Sorry for that inconvenience. I always apologize. So that's why I'm telling you that you critique somewhere and we to adjust. So it was 50, then add 5, and 5. So now you look at this, we can only reduce by what? 5. And when you reduce by 5, this one is a 9. Reducing by 5 there, I think this will be a 10. And reducing by 5, that will be a 30. So the total ratio here becomes 9 plus that's a 9 plus 10 plus 1. I think that gives us 20. Yeah. So meaning that we are sharing this 9 to 5 to 10 to 1, and that is our total ratio. So this changes everything. We're saying that it should be equals 9 divided by our total ratio is 20, then times the cost. This one is distributing first. It is B distributing first because it has the highest cost. All right. So that's how we come with that. We do the same for Y. Again, Y is getting 10 divided by the total, which is 20. It is multiplied by the cost we're distributing, right? And that's what we have. Then again, also A will get 1 out of 20 times the cost of this. So after this, of course, B has distributed its cost. So it becomes, so we subtract it from there. So it has distributed its cost. So it's no longer there. And when you do that, now, you know, I want us to see where this thing comes. So because now we are going, there is nothing here now. If I try to say subtotal and you try to get what I'm talking about, if I do a subtotal that was not, now, if we are trying to do a subtotal, if we add here, this is because this plus that. Now that's what we have. And we do the same throughout, right? So why did we do the subtotal? I'm doing the subtotal simply because I want to show that now we are going to, now department B, department A is the one now distributing. So we come here, sorry, this was department B that distributed first. Now when we come to department B, when we come to department B, I don't know why I'm sticking to B. When you come to department A, so department A now is going to distribute X. It's distributing to X, Y, and A. Sorry, and B. Because the other one distributed to K. Also here, how I wish it was live, you would be showing me everywhere. So even the other one had not adjusted. So department A is distributing X, Y, and B. So when it is distributing X, Y, and B, this will equal to, now it's in the ratio of what? We are saying A is distributing to X, Y, and B in the ratio of 50, 40, 10. 50, 40 to 10. So it is 50% to 40% to 10%. That's all. Okay. This will give a ratio of, now this one reducing by 10, we're getting 5 to 4. So 5 to 4, then to 1. And then our total ratio will be our total ratio will equal to, we are saying 5 plus 4 plus 1. And that gives us 10. Okay. Now we are here. We are now saying x is going to equal to that plus it's going to equal to x is getting 5 divided by the total ratio, which is 10 times. Now listen to this. This was the reason why I made this subtotal. The reason, now A is having this cost, its own original cost from the primary apportionment, plus what B distributed to it. So the total cost that A is distributing is now 349,800. So that is what now we're multiplying with. It is what A is distributing to these people, right? So now even this one is equal to, this one's getting 4 divided by the total ratio, which is 10, multiplied with that. Now it cannot distribute to itself. And now because it cannot distribute to itself, it already has a negative 349,800. Okay. Now this one is equal to, B is getting 1 divided by 10 times this. I hope that is understood, right? Again, I will not be tired of doing my subtotal. I'm not saying that you should always do this, but I'm trying to show step by step why. Now, you see that we are going to distribute this. Here I think I might not do even the subtotal because we are seeing what we are distributing here. But let me do it. Let me just do it. Okay. So it is equal to, remember, we are now not adding from this. We are starting from our subtotal. So I'm just adding this plus what we have been given, right? Also, this is equal to this plus that. Okay, so we do that throughout. So now you realize that what we are going to distribute is now this. B again comes in place, redistribute again. Sorry, I forgot to show the distribution, whatever here. This is 5, the distribution ratios, 5 to 4 to 1. Okay. So again, this guy comes back. I just want to say department. This guy comes back here, but it is department B, and it is in the ratio of 9, 10, I think, and 1. Yeah. So again, B comes back to distribute because it has now this, right? So okay, now this one becomes negative because it is going to be distributed, right? So if it is going to be distributed, we are distributing this throughout. Actually, again, let me copy this. So that is what we are going to distribute this figure. Right? So now doing the same, I'm not going back here. You see we are doing the same whatever. Now again, we're just saying that 9 divided by the total, which is 20. So we are repeating this process here, so long as it is been now distributing. Now, times, you see, it is B distributing. So this is the figure it is distributing. Okay. So if this is the figure it is distributing, we say times that. And that's what we have. Same applies to this, equals, this is 10 divided by 20. Sorry, today I'm a bit so distracted because, like I told you, but bear with me. Please just take what we are doing. Okay, now it is also again distributing to A, which is 1 divided by 20, then multiplied with this. See, like I told you, I'm distracted. 1 divided by 20 times this. And of course, it distributes nothing to itself. Distributes nothing itself. Now, a question is, when we were here, this is what we are distributing. And department A and this, okay, the subtotal, we have nothing here. Now this is what we have. Okay, again, when I come to my subtotals here, because I want to know how much now do we have. Again, like I told you, I might not again just add. Now I see what I'm distributing. You get? So whatever you're distributing now, just like here, just had to put a negative something, negative 34980, because it is what we were distributing. Okay. That wasn't in order. Okay. Now when we come here, okay, I can just go ahead. So what I want you to see that after this 0 here, the new figure for A now, A has this 17490 in that. And now this one will have this negative 34908, because it is what it has distributed. Such that if you're also making a subtotal, you're going to see that now there is 0. Get? If you're trying to do the subtotal here, and you're trying, remember, when we are doing the subtotals, we add in just the previous two, subtotal and this one that B or the any other has distributed. So plus this, enter, and do that all over. Okay, now it is now this one distributing. See, we distribute until it is very insignificant. Yes. So if the figure becomes so minute, then we stop from there. So department A, again, we say that it's going to distribute to X5 divided by the total, which is 10, then times. So 5 divided by 10, that is it. Then times, this is what we are distributing. It is a distributing. Okay? So I've forgotten. This is 5 divided by 10, then times. This is what we are distributing. That's what we are distributing. Oh, okay. Then also this one is equal to 4 divided by 10, then times. Again, we're distributing this one. Of course, here does not distribute. We are having that negative, right? So for it, it is 7, 4, and 0. This one, there is no 0, sorry. But this one does distribute to this. It's taking 1 out of 10 times this. Okay. Again, B comes back. And on its coming back, remember, I always want to put a difference on that, and you see. Okay. So again, if I just bring this here and I do my subtotals, I do this here. So I'll just say this. I start from there, plus this. So I do the same to all of them. So now we are distributing this one. B is distributing that. So it is B that is going to distribute. So if it is B distributing, we see that it is equal to X will get 9 out of 20 times this. That's what we are distributing, right? Then Y is getting 10 divided by 20 times still this. And then this one is getting 1 divided by 20 times this. This one is getting okay. So after that, you see that department A comes back. I'll first add, and I show you what we have. This was my subtotal. Okay. So I'm adding, I start from the subtotal, then plus that, I enter, and that is what I'm doing throughout. Okay, so you realize that now we are going to do that 9, and that is really very minute, if I may say, and we cannot divide this 9. That's what I told you, that until the figure becomes very small, because now if we start dividing this 9, we're going to go in 0 point. So we can stop there and we say, now, this is department A. Department A is the one now distributing. So if it is department A, we see that is X is getting 5 out of 10 times this. And now this one is getting 5 out of X, you know. This is 4 out of 10 times still this equals 4 divided by 10 times this. Then this one is a negative 9. And then this one is getting equals 1 divided by 10 times 9, which is equal to that. So if I just say that the whole of these columns, if I simply go and is the decimal places to 1, yeah, if I happen to reduce the decimal places, that's what I can get. And when that happens, you find that we basically have almost like a 0. So in these subtotals, total, now the grand total, remember this one is my, so now when I'm adding, because I've been adding over and over again, you find that I'm just going to, so when you look at this one was observed because we have removed the decimal places and so forth. So this one is basically like a 0, and it can go to this side because this was a 0 point something, right? So when I add, we are saying equal to this plus that, and we go route, that is what you get. So basically, make sure that this plus this is equal to that, right? So also auto sum from up there. Yeah, I might auto sum. Might auto sum from there and enter. So that's how we can do this. For today, I think we can stop there. Those are the 2 methods we've seen. And next time we shall look at the remaining, which was, I think, algebraic. There are 3: direct, repeated. We have direct, repeated, and algebraic. I think we shall start from there with algebraic. Okay, nice time for now. Okay, so okay, so let me just What's the whole of my whatevers and tables. All right, nice time we meet.